So in this video I want to explain how Mergesort works. Mergesort is a very popular sorting algorithm, and it has many features and properties which are really nice. So the general observation that are exploited by Mergesort are as follows. So if you have two sorted arrays already, so if you have two sorted arrays, it's quite easy to merge them such that you have a common array which is already sorted. You exploit the fact that these two arrays are sorted, and with this precondition, it's very easy to construct something that is sorted again. Yeah, and there's yet another observation which is pretty straightforward, namely that an array of length 0 or 1 is already sorted. Yeah, you don't have to do anything to sort an array of size 0 because there's nothing in it, and you don't have to do anything to sort an array of size 1 because in order to be unsorted you need at least two elements which are in the wrong order. If there's only one element, it's hard to find two elements which are in the wrong order. So that these are the basic operations or the basic observations to see how Mergesort works. Then, namely, the idea of Mergesort is as follows. Okay, since it's easy to merge two sorted arrays, then if we have an array to sort, then we just split that array into two halves. Then we sort them, and we do this with the help of the recursion. And if they are sorted, these two halves are sorted, then we merge them. That's the whole trick. Yeah, so it looks like a miracle, but actually the miracle happens in the recursion. Yeah, and you will see how this is really done when we do the simulation. Okay. Here's the simulation of Mergesort, and it shows 15 elements, so this is the array to sort. And here's the source code. And what you see here is if we make a single, the first step actually, what happens is that we constructed an auxiliary array, so with the same size as the array that we have to sort. So A is the array to sort, and aux is the array that we need additionally for Mergesort. So this is the main drawback of Mergesort. If Mergesort wouldn't have this drawback, sorting would be almost not a problem for the computer science anymore. Yeah. So if we have constructed this array, what we do, we call a method called sort with four parameters. The parameters are the two arrays, A and the auxiliary array, and two integers, namely the position left and the position right. So since we want to sort the whole array, so the left array border is obviously 0 and the right border is the length of the array. So when we call this method, these borders are called L and R, so left and right respectively. So if now we call this method the first time, so what you see is that this frame just says, okay, that is the array that we consider. This is the part of the array that we are looking at the moment. So now what we do now is that we check whether the distance between L and R is too small. If it's too small, then we know that this array, since the array that we consider is too small to be unsorted, then we just have to do nothing. Yeah, so this is just this line is just to check whether this array is just too small to be unsorted, and so obviously this is not the case. So we skip that and don't stop this method here. The next part just computes the middle of the array. So and it's stored in M. So this is the middle of the array, and what happens now is this is the recursive call to the same method sort again, but with L to M instead of L to R. So that simply says, okay, we halve the array into two halves. So this is the first half here, this is the first half, and this is the second half. And now please sort the first half from L to M. And if this is done, then sort the part from M to R. So what happens now is that we just consider this part of the array. Yeah, and we call this method recursively. We do the same steps again. We check whether this array is too small to be unsorted. That's not the case, so we compute the middle of it. It's here, so that's the middle of the array. and then we call the sort method and say okay, sort this again. And now the same steps happen again. So we check whether the distance of LNR is too small. It's not, so we compute the middle. So it's here. So now we have an array of size 1, an array of size 2. And what we see is now we have to consider an array of size 1. Okay, now this should be easy. Yeah, now r minus l is less than 1, so this method should return, okay, we are sorted now, which is true. What happens now is that we now consider that we have returned from this method call, and now we are back in the method call where we considered this array together with that array here. We now sort from this to here. So now make a step and consider this, and the method call now says, okay, now since this is sorted now, sort this array. Okay, so we check whether this array is too small to be unsorted. Unfortunately it isn't, so we have compute the middle, but that's very easy, and then sort the left part, sort it, sort the right part, sort it, and then we do the merge. Yeah, so now we call the merge to these two arrays. So remember, this array is sorted and this array is sorted. So from the left half is sorted and the right half is sorted. So we have two sorted subarrays. And now the merge method is called. And this gets again these two arrays, one array that we have to sort and some auxiliary array. And it gets three integers, L, M, and R, and they are just determining where these two sorted arrays start and where they end. So the first starts from at L, and it's the second starts at M, and the second is finished at R. Yeah, as you see here. So now what happens is in this line is we just copy the contents of this A array to the aux array, which is now done in one sweep. And then we initialize I, J, and K to particular values, such that A points to a position in the left array, J points to the position in the right array, and K points to a position to the destination array. Yeah, I is always the one, the element, the topmost element, or the smallest element of the left array that we just consider, and J is the smallest element of the right array that we consider. K is the position where we have to copy the smallest of both. Yeah, so what we check now is whether K has reached the end of the array. So are we finished already? Now we aren't. So now we do some checks whether I has reached the end of its subarray. No, it hasn't. Then we check whether J has reached the end of its array. No, it hasn't. So then we do the first comparison of elements. So now we check which one is less. So since this one is less, what happens is that we just copy the auxiliary value, this value here, to the destination array over here at the position where K points to. So at the beginning of the array in this case. So now this element has copied here. So you don't see any change because that by this incident is these two elements are in the right order, but you will see the difference soon. So now we proceed with the same steps again. We check whether K has reached the end of the array. No, it hasn't. Now we check whether I has reached the end of the array of its array. Yes, it has. So now I is equal to M. So we don't have to compare anymore. We just know, okay, this array is empty, so the rest is here, and we have to just copy the rest of the array to the top. We just do the copy. Here we are, and then we are finished. So this merge was done, these steps now, and so now we know this array is sorted and that array is sorted. We have two sorted arrays. Now we can merge them. We do the return, and now we are back and consider this array, and we know it consists of two sorted subarrays, namely this is a sorted subarray only, and this is a sorted subarray. We know this now because of this recursive method calls. Okay, now what we have to do is do the merge. Yeah. Now what we do is we do the merge. We copy the values as this has already done now, and now we again do the same steps. We initialize k to the beginning of the array that we copy to. I is the initial index of the left array. J is the initial index of the right array, and then we compare the topmost elements, where I and J are pointing to. So since now this one is less than than that one, we copy this one to this position. Okay, done. So we proceed with the next. We do the next comparison since both haven't reached the end of the array, and we do the next comparison. So we compare this one with that one. So since this is less, we will copy this element to this position. Done. And since we haven't reached the end of the array, we just check whether I has reached it's the end of the array. Since this is the case, we just copy the value from the rest of the array of the other array to the top. So we just do the copy, and then we are finished because we know k has reached the end of the array. So now everything must be sorted in this subarray here. So we have sorted this subarray. Okay, we call back the method that called us, and now this says, okay, now we know this is the left subarray, and now we know by construction this is sorted. Now we consider the right part, and we do the same steps again. Please sort this. Yeah, okay, we halve it, and we sort it. So we sort it by halving, and then we sort this. This is sorted. This is sorted. Now we have two sorted arrays. And now we do the copy, and then we do the comparison. This was smaller, so we copy it to this position, and this is the remaining part of the other array. The one is empty, the other isn't, so we just copy the rest because we don't have, and since we know the other one is empty, we don't have to compare anymore. So now we have a sorted subarray, as you see, and now we consider the second part that we have to sort. Okay, halve it. Okay, this is sorted. This is sorted. Okay, copy, and now do the compare. Now initialize the indices and then do the comparison. Okay, copy the minor one and copy the larger one. Okay, now we have two sorted subarrays. This array is sorted and this array is sorted. Now we just have to merge them. Okay, copy first. So we copy everything to the array at the bottom, and then we do the merge. So we initialize all those indices and then we compare. So in all cases we compare the element at the ith position with the element of the jth position, and we always copy the small element to the position where k is pointing to. Okay, we copy the smaller one. So now we don't have to consider this one, and we just have shifted the j. Okay, now we compare these two elements. Okay, this one is smaller, so we copy this to this position. Here we are. And now we know this array is now, this subarray is empty now. There's nothing to compare with, so we just can copy the rest of this array to the end of the remaining array here at the top. So copy, copy, and then we are done. Now we have two subarrays. This subarray is sorted, and this subarray is sorted again. We do the merge. Here we are. We do the copy of both arrays to the auxiliary array, and then we do the merge. Now with 7 elements in total. So I think now the procedure should be clear, and you see how it works. So step by step we fill the array at the top with the sorted array. So now we have sorted the first half of the whole array, and then you have to consider the second one. So I guess that you have now understood what's going on here. I just proceed with the automatic simulation here. You see again, sorted, merge them. Okay, now this is sorted. Consider this array, halve it. This is sorted, copy and merge. Okay, now we have two sorted subarrays. Copy them and merge them. Here we are. And now we do the same game at this part. Halving. Oh, this is sorted, merging. And finally this subarray, halving, this is sorted, merged it. Now we merge these two subarrays here from here to there, because we know that they are sorted now. Okay, just merge them. And then we are done. Now we have two subarrays which are sorted. This is sorted and this is sorted. Copy and do the merge. And finally we have two sorted subarrays, so we do the copy and then we do the merge as before. And we will end up with an array which is sorted from the beginning to the end. Yeah. So the main drawback of Mergesort is that we need a second array. So if you consider the sorting algorithms that we have considered so far, you will see that they don't need an additional array. They just need some minor set of variables, but not the whole array. So this is the price we have to pay if we want to use this nice sorting algorithm called Mergesort. Actually, it's more or less the only disadvantage. So now it's sorted, and you see there are just 39 comparisons, and if you will check the same numbers for insertion sort, you will see this is already smaller. Yeah, so this is in the following video that discusses the complexity issues of Mergesort, you will see that this is substantially better than insertion sort or selection sort.